Hello, my name is Amangeldikyzy Ademi from the Group Software Engineering 2106. Today I will define models between 8 and 10 communicating between networks and the models between 11 and 13 IP addressing. So let's start. First model is network layer. The main objective of this model explains how routers use network layer protocols and service to enable end-to-end connectivity. So the top model includes sub-models like network layer characteristics. It is explain how the network layer uses IP protocols for reliable communications. Next one is IPv4 packet. It explains the role of the major header fields in the IPv4 packet. And the next one is about IPv6 packet. In this module, we will discuss about the role of the major header fields in the IPv6 packet. So next is how a host rules. How network devices use routing tables to direct packets to a destination network. And the last one is about introduction to routing. It explains the function of fields in the routing table of a router. So conclusion for eighth model, it is from the eighth model of the course network computer network. I learned how the network layer uses IP protocols for reliable communication, the role of the major header fields in the IPv6 and the IPv packets. This model explains how routers use network layer protocols and services to enable end-to-end connectivity. So next model is about address resolution. First submodel is about introduction. What will I learn to do in this course? The model objective is explain how ARP and ND enable communication on a network, and it includes sub-modules like MAC and IP. It is compared the roles of the MAC address and the IP address. And the next one is about ARP. It describes the purpose of ARP, and the neighbor discovery describes the operation of IPv6 neighbor discovery. And in this model we have packet tracer identifying MAC and IP addresses. How you can see, so identifying MAC and IP addresses, we need to firstly gather the video information as a packet travels, and give IP addresses for this and answer the reflection questions. So I can answer for several for them, like did the wires change handling of the PDU in one anyway? Its answer is no. And if the simulation was configured with IPv6 instead of IPv4, what will be different? The IPv4 addresses will be replaced with the IPv6 address, but everything else will be the same. So next model is about ARP, and we also have packet tracer examining the ARP table. So objectives of this packet tracer is examine ARP requests, examine the switch MAC address table and the ARP process in remote communications. background. This activity is optimized for viewing PGUs, and the device is already configured. So if we click the button check results, we can see that it is completed. We completed this activity. So also in this model we have reflection questions, and I answered in this Word document. So next sub-model is about IPv6 neighbor discovery, and also in this sub-model we have packet tracer. So you can see that main objectives of this packet tracer is IPv6 neighbor discovery local network. In the next part 1, part 2 is about IPv6 neighbor discovery remote network, and also answers the reflection questions. If we click the check results, we can see the answer we did it completely or not, because it's logged by after design for this activity. So and you can see also in this Word document answers for this packet tracer. So conclusion for 8 model. This model explain me how ARP and enable communication on a network. Also give me knowledge about MAC and IP, that layer 2 physical addresses I use it to deliver the data link frame with the encapsulated IP packet from the NIC to another NIC on the same network. ARP request is received and processed by every device on the local network, which could cause the network to slow down. Neighbor discovery provides address resolution, route discovery, and redirection services for IPv6 using ICMP v6. So next topic, next submodel is about basic router configuration. First submodel is about introduction. What will I learn in this model? The main objective is implement initial settings on the router and end devices. First submodel is configure initial router settings, and the topic is objective configure initial settings on an iOS and Cisco router. So let me open this packet tracer first. In this first model, the main objectives of this packet tracer, it is configure initial router settings. Main objectives is verify the default router configuration, configure and verify the initial router configuration, save the running configuration file. You can see that PCA and R1 is connected by it is connected with this connector. So if we click the check results, we can see that we completed this activity. So also you can see in this Word document we answered the reflection questions and the questions between part 1 and the part 3. So next one is configure the default gateway. It is submodel 10.3, and it is about configure devices to use a default gateway. So we can see that main objectives is verify network documentation and isolate problems, implement, verify, and the document solution. And you can see that it is completed 100%. So So for conclusions, tense model I learned in this model next. Configure the device name, secure privileged access mode, secure user access mode, secure remote telnet SSH access, secure all passwords in the config file, provide legal notification, save the configuration. Also, this model implement initial settings on a router and end device and explain how to configure interfaces in the default gateway by use the IP default gateway and the global configuration command. And the next is assignment 4. Assignment 4, it is model is between 11 and 13, and the topic name is IP addressing. So IPv4 addressing, it is next model is 11th model. First is model introduction. This model giving knowledge about how to calculate an IPv4 subnetting scheme to efficiently segment my network. So it is included submodels like IPv4 address structure. It describes the structure of an IPv4 addressing, including the network portion and the host portion and the subnet mask. And the next one is about IPv4 unicast, broadcast, and the multicast. It is compares the characteristics and uses the unicast, broadcast, and the multicast IPv4 addresses. And there, as you can see, we have an activity. We should in this activity activity it is about unicast and broadcast or multicast. We need to write destination IP address and check the results. So you can see the results, it's 5. So next one is types of IPv4 addresses. Types is IPv4 addresses also have an activity, as you can see that we need to decide the path block and each IP address depending on whether it's public, and if we lose the points. Also we have activity in this case, and you can see answers was correct. So next one is network segmentation. Network segmentation, it's about broadcast domains and segmentations. And the problems with large broadcast domains, reasons for segmenting networks. In this case, we can see how to connect the internet and broadcast domain. Also how to connect it LAN 1 and LAN 2 with 200 users with internet. So next one is about subnet and IPv4 network. And this model is about subnet on an octet boundary and have packet traces, subnet and IPv4 network. So let me show the answers. I'll open the packet tracer. This is 11, 5, and 5. So you can see that it is completed 400%, and the main objective of this packet tracer is design an IPv4 network subnetting scheme and configure the devices, test and troubleshoot the network, and answer these questions in the situations. So if we click the check results, we can see that it is completed. 400%, like exactly. So next subtopic is about subnet /16 and /8 prefix. In this model, we create a subnet with /18 16 prefix, also 100 subnets and 1000 subnets with 8 prefix, and we did activity completed. So next one is about subnet and meet requirements. In this model, we also have activity. You can see that determines the number of bits to borrow. VLSM. It is next topic. So variable length subnet masking, it's explained how to create flexible addressing scheme using variable length subnet masking. And the next one is structured design. It is implement a VLSM, variable length subnet masking addressing scheme. And the next submodel is and the last model is about model practice and the quiz. And in this submodel we have packet tracer, designing and implement a VLSM addressing scheme. So you can see that main objectives is design a VLSM IP addressing scheme given requirements, configure addressing on network device and host, verify IP connectivity, troubleshoot connectivity issue as required. We have east and west routers that connected with other computers, and as a result we can see we fill at this table and completed this activity exactly. So in conclusion, 11th model, I can say that this model learned me how to calculate an IPv4 subnetting scheme of efficiently segment my network and give me knowledge about IPv4 address structure that describes the structure of an IPv4 addressing, including the network portion, and explain how subnetting segments in network enable better communications, how to create flexible addressing scheme using variable length subnet masking. So next model is about IPv6 addressing. First is introduction. Main objective of this model is about implement an IPv6 addressing scheme, and it is included subtopics like IPv4 issues, IPv6 addresses, and I will scroll down this Word document. You can see the answers that my works that I learned, and results of how I pass the exams. So next one is IPv6 address representation. It's explain how IPv6 addresses are represented. Next one is address types. Compare types of IPv6 network addresses and the GUR and the LLA static configuration. It is explain how to configure static global unicast and the link local IPv6 network addresses. And in this case we also have activity, so you can see that it is completely fine. And the next one is dynamic addressing for IPv6 GUES. So first answer is false. Let me show the answers. So First is true or false array messages assigned to all IPv6 orders by host request addressing information is false. And the next one, CLAAS. So next answer is stateful digit as IPv6. False one is about method 2, and the fifth is so next one is about dynamic addressing for IPv6 LLAS, and we also have in this model packet tracer configure IPv6 addressing. The main objectives of this configure IPv6 addressing. It is objective is configure IPv6 addressing on the router, configure IPv6 addressing on servers, configure IPv6 addressing on clients, test and verify network connectivity. And we worked with this source, billing, accounting, and design. We need to firstly change IP configuration. We change IPv6 address, also default gateway that is shown on this table, addressing table. Also, we will work with like billing. In IPv configuration, we change the default gateway and IPv6 address, also accounting, and we need to one of this browser. We need to open the web browser. And pass this. So where is this? Pass this address. And we can see that result. It is about accounting server. And if we pass this address, we can see is results at website. So let me check. Yeah, it's at server. So it's completed 95%. I can found the mistake. So that's all. And next one is about subnet and IPv6 network, and the last one is about model practice and the quiz. In the conclusion, 12th module. In this module, I learned how to implement in IPv6 addressing scheme submodule IPv4 issues explained for need for IPv6 addressing, GUI and LLA static configuration, and how to explain also configure static global unicast and the link local IPv6 network addresses. So next model is about ICMP. ICMP, it is use various tools to test network connectivity. And first model, submodel, it is about ICMP IPv4 and ICMP v6 messages. In this topic, I learned about the different types of internet control message protocols and the tools that I used to send them, the types of ICMP messages, and the reasons why I sent are extensive. And you can see that packet tracer is answered in the 13.2 ping threshold tests, and it's completely and it's completed so you can see the answers for these reflection questions, also questions part between 4 and 5. Conclusion, 13th model. I learned in this model about ICMP, more precisely about ICMP messages sent using ICMP, the purpose of these messages, and how to provide feedback about issues related to the processing of IP packets under certain conditions. Fortunately, there are tools to help me locate problem areas in my network, and they work with both IPv4 and IPv6 networks. So that's all. It was packet tracers, also checking my understanding of these modules, and conclusion in these modules. So that's all. Goodbye. See you later.